Hello, Honors Algebra 2. Sorry, my kids are asleep, so I'm doing this a little quietly. So I got the mic really close to my mouth. I hope it sounds okay. I did a little sound check. I think it's fine. There was one example that I didn't get to in 6th period today. So you might be able to figure it out even without my example, but I'm just doing this just in case there was anything confusing about this, because it is a little different than what we did in class. It's from the packet I gave you yesterday. I meant to go back to it and we ran out of time. Okay, so the question is this. Consider the function y equals f of x So consider the function y equals f of x, and it has a domain -5, 6 and range -4, 4. That's all we know about the function. We don't know anything else. So what that means is that the function has a domain of -5 to 6, a range of -4 to 4, and what that means is the entire function lives inside of this box. And who knows, the function could be just a line segment that connects these two corners like that. It also could be something that goes like this, and maybe it has a hole right here, or like a open end, and then it jumps down here, and then it comes up like that, and it includes that corner. So there's infinitely many examples of functions that live in this inside of this rectangle and have this domain and range. Okay, so but we don't know exactly what it is. So they're saying, hey, f, which has a domain inside of that box we just drew, f is being transformed in the following way to make this new function. And the question is, what is the domain and range of the new function? The key is this. We write down the coordinate transformation. We write down how f of x is transformed into a of x. So I've written down the coordinate transformation that corresponds with this transformation. Of course, the x is not being transformed at all on the inside, so that's why x just maps to x. X doesn't change. And y is -3 plus 1, so -3y plus 1. Okay, now the key is that the domain are x values. The range are y values. So the x transformation changes the max and min of the domain, and the y transformation changes the max and min of the range. So let's get those numbers. I'll do the domain in red because I colored it red there. So, oops. So, -5 is the min of the domain, and that just maps to -5 because the x transformation does nothing. And the 6 maps to 6, so the domain actually stays the same, -5 to 6. What about the range? Well, the old min of the range was -4, and that's going to become -3 times -4 plus 1, which is 13. Yeah. 13, yes, okay. And then 4 maps to -3 times 4 plus 1. So -12 plus 1 is -11. Notice in this example, this minus sign actually swaps the range vertically because that minus sign flips this over the x-axis. So what used to be the minimum of the range became the maximum of the range. and what was the maximum of the range became the minimum. So the most common error that students will make is they will just write it 13, negative 11 like this, because negative 4 was on the bottom and that became 13, so they'll put it here. But that doesn't make any sense, because you can't have the lesser number on the left, the greater number on the left and the lesser number on the right. So I'll fix that. This is negative 11 and 13. Okay, that's it. So there's 3 others to do, and the answers are in the notes. The other example I want in the video is to just explain how to start this. Find the domain and the range of the following functions. So we have this. We're not going to graph it. We're just going to find it directly because it only asks for domain and range. The parent function is the square root of x. What's the domain of square root? The square root function looks like this. The domain is all positive and 0, so non-negative numbers. And the range is the same. Okay, so that's the parent. And now the transformations are the following. So g of x is negative 3. Now, of course, on the inside, we need to factor out the leading coefficient. We need to factor out the leading coefficient and double check our signs and everything. That looks good. And we get our coordinate transformation. And our coordinate transformation would be negative 1/5 x minus 11/5, comma, negative 3y plus 6. And we do the exact same thing. So it turns out this is quite easy, because the domain is 0 and infinity, min max. It's not really a max, but I'm just saying the right-hand side of the domain. It's not actually a max. So this is domain. And then what does 0 map to? 0 maps to negative 11/5. What does infinity map to? Well, negative 1/5 times infinity is negative infinity. It flips the domain around the other way. So this becomes negative infinity, and the range, min max, is 0 to infinity. So, and then so 0 maps to 6, and infinity maps to negative infinity. Now notice this did the same thing, where this minus, which is this minus, is a reflection over the y-axis. This minus on the outside, which is this minus here, is a reflection over the x-axis. So these swapped max and min from the original. Okay, all right. So my battery just died on my tablet. So anyway, that was enough I wanted to show you anyway. So I wanted you to try to finish that, and the notes and the answers for the entire packet are in the shared drive. All right, see you in class.